everyone, welcome to our second mini lecture about exponents. Some more fun with those exponents. So in our first video, we talked about those 5 major rules about the things we can do with exponents. In this video, we're going to talk more about a handful of things that you're going to encounter with exponents that we didn't get to in those 5 main rules. And we're going to finish off this video talking about what it means to simplify an exponential expression. So if you'll remember from that first video, we only saw exponents that were positive integers, right? We saw 2s and 3s and 7s and 127s, right? Just nice positive integers. But what would happen if those exponents were either 0 or negative? So let's start by attacking that case where the exponent is 0. So as you'll see in this rule that you see at the top right corner there, x to the 0th power is 1, right? And what that really means is anything that I take to the 0th power is just going to be 1. So I could take x to the 0th, I could take 2 to the 0th power, that's just 1. I could take 7xz all in parentheses raised to the 0 power, that's 1 as well. I could take 1000y, that to the 0th power is going to be 1. Doesn't matter what it is, taking it to the 0th power is going to give me 1. Okay. To motivate this a little bit, right, just a rule that seems to come out of nowhere, but to motivate it a little bit, let's think about that quotient rule actually. So I'm going to start with the right-hand side. I'm going to start with thinking about what 1 could be equal to. Well, 1 could be the same as, anything on top of itself. So maybe let's think about 5 squared over 5 squared. But if we go back to that quotient rule, 5 squared over 5 squared, that should be 5 to the 2 minus 2. But 2 minus 2 is 0. This is just 5 to the 0th power. And I could repeat this process with any base that I want to. Right? I could repeat it with the 2, I could repeat it with the 7xz, I could repeat it with any term I want to. Just turn it into a fraction equivalent to 1, and it'll get me back down to that base to the 0th power. Right? That motivation is pretty cool. Realistically, we mostly just need you to know how to do this more procedural thing on the left. Just taking it to the 0th power and knowing that that's 1. Okay, so that covers one more thing. Then we also want to think about what happens if I have a negative exponent. Right? Because we said that exponents are just shorthand for doing multiplication. So it makes sense. 2 to the 3rd is 3 copies of 2 multiplied together, but 2 to the negative 3rd doesn't have an intuitive explanation. So you'll see this rule on the top right. If I have something to a negative power, what I can do is I can flip it underneath the fraction bar, and I'll make that exponent positive. So to give this some motivation, we're actually going to think back to that quotient rule again. So I'm going to start again with what you see on the right-hand side of that rule. I'm going to start with that 1 over x to the 8th power. Now, we just learned from those 0 exponents that 1 is the same as anything to the 0th power. So this is the same as x to the 0 over x to the a. And using that quotient rule, this is going to be x to the 0 minus a power, or just x to the negative a power. Right? So that quotient rule actually shows us that this definitely is a true thing. But in practice, all we want to do is just, if we see a negative exponent, we want to flip it over the fraction bar. So you see here the x to the negative a is 1 over x to the a. We could also do it the other way. So for instance, if I had 1 over y to the negative b, that would be the same as y to the positive bth power. So we can flip it either direction, and it'll make that negative exponent positive. Okay, so that deals with the negative in the exponent. We also want to talk really quick about what's going to happen if you have a negative in the base. So you'll see up here we have negative x to the a, but one set has parentheses, one set doesn't have parentheses. And that actually means 2 different things. I'm going to do an example with some numbers. So let's do that first case without the parentheses there, and we'll think about negative 2 to the 3rd power. So in this form without the parentheses, what it's telling me is I leave the negative out front, and then I'm going to multiply together 3 copies of 2, and that should give me negative 8. Okay. We could do the same thing with the parentheses. So now with the parentheses, instead of leaving the negative out front, what it actually is telling me is I want to multiply together 3 copies of negative 2, which in this case also gets me back to negative 8. So you're going to see in a lot of these cases, the difference between the parentheses may not change the end result. But there are definitely cases where it is going to change that end result. So let's consider it again, but instead of 2 to the 3rd, let's try 2 to the 2nd. So if I do negative 2 to the 2nd, again without the parentheses first, I'll leave the negative out front, do 2 times 2, that'll give me a negative 4. this time, if I throw in those parentheses, if I have -2 times -2 like this, I'm going to end up with a positive 4. Right, so we want to be really careful. Actually, anytime you see that an even exponent like that, we're going to have this difference in sign depending on whether we've included those parentheses or not. So we do want to be super careful when we see those parentheses cropping up. All right, that covers a lot of the things that you're going to see with exponents. So the last thing we want to talk about is what we mean when we say to simplify an exponential expression. So if I ask you to simplify an exponential expression, you're looking for two major things. The first is that you don't want to see any negative exponents. And the second is that you want to try and get the fewest copies of the same base as possible. So like the fewest copies of x that you'll see and the fewest copies of y, something like that. We'll start with one slightly simpler example, and then we'll do kind of more of a confusing example, maybe the most confusing that you'll come across in this class. So for this first example, let's consider 2x to the -2 all over y to the -4. So we actually see with this one, we already have the fewest copies of x and y as possible. But we do have to get rid of those negative exponents. If we think back a couple of slides ago when we were talking about those negative exponents, to make them positive, all we do is we flip them over the fraction bar. So I'm going to want to take that y and I'm going to want to flip it to the top. So I'll have a y to the +4th on the top now, and then in that denominator I'll have an x to the +2. And then this expression is actually as simplified as it can be with just that one step change. All right, let's do one more example that's maybe a little more complicated. We're going to do a bigger fraction this time. We're going to do -4 x to the -3rd y squared all over x to the 6th y. And I'm going to take that whole fraction, I'm going to take it to the 2nd power. Okay, there are a lot of things that you can start with in this expression. And anywhere you start is totally fine. For instance, maybe you want to start with that 2 on the far outside, give it to all of the terms. Maybe you want to start by combining both of the bases of x, combining both of the bases of y. Maybe you want to start by getting that x to the -2 as a positive exponent. Right? There are a lot of different ways that you can approach this problem. I'm just going to show you one way, but know that you can definitely go any way that you see fit. Okay, I'm going to start out actually by taking that 2 on the far outside and giving it to each one of my terms. So I'll take this -4 and square it, x to the -2 squared, y squared squared, all in that numerator. And then the denominator, I'll have that x to the 6 squared and that y squared. Right, so that was a combination of rules 4 and 5, that quotient rule, product rule combination that we talked about at the end of the first video. The next thing I think to do is to do that power rule, right? I see a lot of things that are a base to an exponent and then that whole thing raised to another exponent, so I want to simplify those. So let's start with this -4 squared, right? That's just -4 times -4 should give me a +16. X to the -2 squared, right? I'll multiply the -2 and the 2 together to give me an x to the -4th. The y squared squared, I'll multiply those 2's together to get 4. Then the denominator, x to the 6 squared, that'll be x to the 12th. And then the y squared is that last thing there in the denominator. Okay, from here, I'm going to try and reduce the number of bases that I see, right? So for instance, we see 2 different copies of x. We have that x to the -4th in the numerator and the x to the 12th in the denominator. I want to combine those. I want to do the same with those 2 y's that I see. So for this one, we're going to fall back on that quotient rule, right? I have the same base, different exponents. I'm going to subtract them. So I'll let that 16 hang out front, and then I'll have an x to the -4 minus 12 and a y to the 4 minus 2, right? Or simplified out, that'll be 16 x to the -16th y squared. All right, so now I have the fewest number of bases as I can. I want to do that last rule. I want to get there to be no negative exponents, right? So I see that -16 exponent on the x. So I want to flip that down into the denominator. So that'll be 16y squared left in the numerator, and that x to the 16th in the denominator. And that'll be the simplified version of that expression.